So welcome back again. This is the sixth part that in this we are going to discuss some of the numericals that we have studied. Now we are aware about some of the topics that was the KCL equation we have studied. We know about the KVL equation. Then in this we have the nodal analysis by using the nodal analysis, and we have the loop analysis. So, and we have some of the tools that can be used, some of the tools that we have studied that were that was voltage division rule, and we have the current division rule. With that we have the star to delta transformation, and that is delta to star transformation and star to delta transformation. So these were the tools, and we have basically we have the numericals based on this nodal analysis and the loop analysis. And in this we are going to cover the two topics, that is the dependent sources and independent. So coming to the first slide that we have right now is, so we have one numerical, that is the first numerical is that we need to find out the unknown resistance. In figure this, the voltage drop across the 500 ohm is given, that is 2.5. That is across this the current is given, that is the voltage across this is given, that is 2.5 volt. So the first approach when we are going to start any numerical, first of all we have to use the current direction. We have to consider one current direction, and we need to satisfy the KCL equation, that is the summation of all the current should be equal to the 0. This is, so coming at this point we have, it has given that the all the resistance in the ohm, this is the ohm value has been given, and now we need to find out the resistance, we need to find out the unknown resistance R if the voltage drop across this this is 2.5. Now we know that these three are connected in parallel. So if we see that in 500 ohm we have the voltage, we can calculate the current across this terminal. This, if I consider this as a I2, I can calculate the I2, that is these two are in series, and this is a voltage across this, that is 2.5. So we can calculate the current across this terminal. When the current across this terminal is calculated, I can go for I can use the nodal analysis. As it is not specified, I can go for the nodal and across this voltage, if we consider that is this the VC. If I know the current value of I and the V, then I can calculate the R. So this is the approach we are going to use it. So coming forward, as we can say, we have calculated the current across the I2 terminal, that was I2, that is the voltage that is given, that is 2.5, and the we have the resistance value, that is 500 ohm. So we have calculated the current across this. Now that means if I was the current, I1 was given here and I2 is given 0.005, we have calculated, that means it, the current that is going across this is I1 minus 0.005. We can say that that is I1 minus of 0.005 will give me the value of I can say this. So for this, what we are going to do, we are taking the, we have calculated the voltage across this terminal, as we know the current value, so we can calculate these two are in series, and I can calculate the voltage across this terminal, that is a VC. So we have calculated the value, that is VC value we have calculated, that is 2.75. Now this is the current that is going, we have the voltage across this, so I need to find out the value of I. That means this is the current division rule that we have said, that is I is going to split into I1 plus I2. This is the basic equation, or I can say that the I minus of I1 or minus of I2 should be equal to 0. So we have the value of I2 and we have the voltage across this, and I need to find out the current across this. So I is given, so I can say that I will be equal to the voltage minus the voltage across this terminal, that is 2.75, divided by the total resistance. The total resistance across this terminal is 550. So we have taken 550 and we have calculated the value of I. So I know the two value. This is we have calculated 0.168. We have calculated and I2 was 0.05. So I can calculate the value of I1. So I1 can be calculated at I minus of I2. That is as I was saying that I will be equal to I1 plus I2. If I need to find out the value of I1, it will be I minus of I2. Simple. So this is how we are going to calculate, and we have calculated the value of the current across this. Now we know the voltage. So voltage upon the V is equal to IR. Using the Ohm's law, we can calculate the value. R has been calculated. So now coming to the next numerical that we have right now is this. Coming to the next numerical, I think this is clear to you all. This is the first thing that we have to remember is the current division, that it should follow that the it should be equal to the zero, the current. Now we have this numerical. The three resistors are connected as shown in the figure. Find the equivalent resistance between the point A and B. This is the point it is asking across this. If I say this is a voltage. If I connect it to some of the voltage across this terminal, so I can calculate that which is the which are in series and which is in the parallel. So by this we can say that the equivalent resistance can be calculated. That is, these three are in parallel. We can calculate it, R1, R2, and this. Now coming to the third numerical. This numerical is really very important, because if we go for the gate examination or somewhere, it is one of the favorite question that has been asked. How it is saying that the 100 watt, it is saying that what, a 100 watt 250 lamp is connected in series with the 100 watt. So we should have the one visual regarding this. If this is the 100 watt volt, it is connected in series. It is connected in series with the 100 watt 250 volt lamp. This is the 250 volt lamp is connected with a 100 watt system with 200 volt. That means 250 volt and 200 volt is there. 200 volt across 250. So calculate the current and the voltage across each lamp. So how we are going to move forward, we are going to see how we are going to solve this. We know that the power is equal to P is equal to VI, and if I say that, then I can calculate the value of R that is given across this terminal. The R can be calculated, that is V square upon of P. By using this formula, we can calculate the resistance across this. The resistance across the 100 watt 250 volt we have calculated, and the 100 watt 250 volt ramp R2. This is the R1 and this is the R2. As I said that this will be one having the resistance, this one R1 and R2. So when the lamps are connected in series, the total resistance, this means the across this, if I say this was the R1 and this was the R2, so the total resistance across this terminal, if I connect with the voltage source, the total resistance will be R1 plus R2, that is 1025. So the total current we can calculate, the total current I can be calculated, that is 0.244. So the voltage across 100 watt 250 volt can be calculated by this, and the voltage across 100 watt 200 volt can be calculated like this. So this is the other example that we are going to take. This is the numerical that is saying we need to calculate the current. Find the value of the various current in the circuit shown in figure 2.23. What is the total conductance and the total resistance? So it is asking for the conductance. We have to remember that what is the symbol that is given. So here we know that R is equal to 1 upon G. So the value of this is the conductance, that is we need to calculate. So how we are going to calculate, it is given that the 12 ampere current is going across this. So the I is equal to, I can say that the I is equal to 12 that is going inside it, and it is getting distributed into three currents, that is I1 plus I2 plus of I3, and it is going to ask me what is the total current across this I1, I2 and I3. Now, and in the last it is asking the total conductance. That means if I calculate the resistance, this will be 1 by 1 upon 0 1 upon 0.4, it will be 1 upon 0.1, it will be equal to 1 upon 0.2, and it will be equal to 0.3. This is the resistance value. So I need to calculate the total voltage and the resistance. So how we are going to approach for this? This is the simple approach that we are going. We have studied the voltage division. We have studied the current division rule. Across, this is how we calculate in the current division rule. If I need to calculate the value of I in one, then I'm going to calculate the total current that is flowing inside it, the total current that is going to across this into the resistance across which I have to calculate. For example, if I give it the name R1, it will be R1 divided by the total resistance that we have that was the equation. So the total in the place of R equivalent, we have the G value that has been given. So we will take the GBC. So this is how the I1, I2 and I3 is calculated. We have calculated. Now it is saying that the GAB, that was 0.4, that was 0.4 conductance was given, that is mho. Then GBC was given the total. We can calculate the total. These this can be calculated like this. The total GAB is calculated, and the reciprocal of the conductance we have taken, that will give the resistance across this. So we have another question now. All the resistance in the given are in the ohm. Find the effective resistance between the point A and B. It is going to ask me what's the total resistance across the terminal, that is A and B. So this is how we are going to calculate. If I say this was the I current was flowing through this, this will be going, and this is going to distribute into, this was I. So if I1 is going across this, so it will be I minus of I1. Then across this terminal I1 is going, so it will be if I take this I2 as this I2. So this is how the current distribution we will do. The current distribution is done. The current that is going from this and this, so that the total current that we have said, that the I should be equal to I1 plus I2 plus I3 plus IN, that we have said. So how we are going to calculate? We don't need to calculate it. How? Because if we know the concept of series parallel combinations, how we are going to solve it? We can solve it very easily by seeing that if I said these two in the current in the series, we said that if we are going for the series, if we are going for the series circuit, the current remains same. So, and in the parallel, the current is distributed. That is I2, IN. It will be IN. So these two are in series. These two are in series. So the total resistance will be 6. This 6 and 6 is in parallel. So the resistance that we have obtained, that will be 3 equivalent resistance, that is, and 3 and 3 again will be in the series. This will be the 6, and the 6 and 6 are in the parallel, so it will be again, it will be 3, and 3 and 3 again in the series, it will form the 6. And 6 and 6 in oh, sorry, and these two are in series, so it will be the 6. So 6 and 3, 6 again, it will form a 3. So in the last, what we have obtained the resistance, that is 3, and across this, then we have the resistance across this, that is a 3, and the resistance across this terminal is 3, and this is A, and this is B. So these two are in series, that is 6 into 3 divided by 6 plus 3, that will give the total equivalent resistance across A and B. This is how we solve it. So we do not need to calculate, because if we know that. So these are the questions that is really asked in GATE or some of the competitive exams, which they don't need you to calculate. They, by seeing it, you can calculate it. So this is how we calculate. This is the calculation, and we have obtained that is 2 ohm. So now we have next question that is given, find the current flowing in all the branches. So it is saying that we need to calculate the current in all the branches. The current that is given is I1, that is already given. The direction of the current, we cannot choose the direction of the current, because it is already given that this will be I1 and this is I2, and this is the combination of I1 plus I2. That means the current that is flowing across this is I1, and again the current meeting at the node, it was I2. This is going to give the current that is I1 plus I2. That means it is, if I take this will be equal to 0. That is, the summation of I should be equal to 0. That means it is already satisfied. So how we are going to do? We need to calculate the value of I1 and I2 and I3. So if I take the first loop that has been given already, so the current direction will be somewhat like this. It will be going like this. So I need to calculate, if I start from this point. If I start from this point, it will be 2 I1, it is going at the C, it is going downward. So I will say the first voltage that we are having, that is a positive terminal, this is positive and this is negative. So the positive is coming, and then if we see at this point, we have taken the direction that is this one, but it has given the current direction in this way, so this is opposite. So what I will do, I will take this as a 5 5 of 5 of I2, and then again it is going at this point, it is minus of 30. This is the first equation. Now going to the second equation, if I start from this point, so it will be somewhat 3I1 plus I2, that has been specified already. Then going at this point, this is positive and this is negative terminal, so I will take as a 5. Then at this point it is going downward, and the direction of the current is the same that we have taken, that is we have taken this direction. So this will be the 4, this will be the 4 I1 plus I2, because this was the current that is flowing across. No resistance is there, so the current will remain same. So coming at this point, this is the 4 volt, this is 4 ohm. Now coming at this point, it is getting the negative, that will be equal to, so that means that is the direction that we have taken. It is the direction of the current, that is I2. We have taken the I2. It is the same direction as we are taking. So I2 will be like this, and this will be the 5 ohm. And now coming at this point, it is having a negative terminal, that is minus of 10. So it will be minus of 10 volt is equal to 0. This will be the second equation. So now let's see how uh, the two equations has been calculated, and we have the two unknowns, that is I1 and I2. If we are going, as when we are going to solve it, we are not going to solve it, we will use the calculator. If I go for the calculator, we have this suitability that if I put the 2 in the calculator, I can calculate the two values, that is I1 and I2, by putting into the equations. So this is how we have solved. We have this equation first, then we have the second equation that we have calculated this one, and in third we have here using this, by applying this, by taking the same coefficients, we have calculated the I1, the I2 can be calculated, because this will be subtracted, 14 will be calculated, and this will be 2.2 ampere. So this was the I2 value. If I know the I2 value, I will put in any equation. We have the two equations, this one and this one. Putting in any equation, I calculated the value of I1, and the total current across this I1 is equal to I1 plus I2 is equal to I1 plus I2. So we can calculate the total current across this terminal. So now coming to the next numerical, it is saying that determine the current. It is going to ask me determine the current in 4 ohm resistance for the circuit shown in 6.29. So this is the given, that is it is going to ask me what is the 4 ohm resistance. This is the 4 ohm resistance. 4 ohm resistance is given, and it is going to ask me find the current in 4 ohm. So that means I need to calculate the current across this terminal. So according to the first rule, we have to divide the current. So this is the simplified version that we have taken. The simplified version, we have said that if this was the I1 current, this was the I1 current. If I have taken that, that means I need to calculate the value of I1 finally. We need to calculate the value, that is I1. So the I1 was flowing this point, and we have taken the current that is going, that is I2 is going this way. This was I1 and this is the I2. That means the current that is flowing in this terminal, that is going across this terminal, will be somewhat I1 minus of I2. If I1 minus of I2 is going this way, so that means at this point the 6 ampere current is coming, and it is connected to the node, so that the two currents will be I1 minus of I2 or plus of 6. That means the current that has came at this point. So we have the current across this. Now if I take this as a I3, I have taken I1 I2, and if I take this as a I3, or if I take this as a I3, if I take this as a I3, so the current will be the summation of this. So it will be somewhat I1 minus of I2 plus of 6 and plus of I3 will be the total current that will be flowing across 2 ohm. Now this is a voltage source, so I don't in this. Now if I have taken this I3, so now in this what will be the current? That was, we have taken this I2, this was the I3, that means this is going this will be equal to I2 minus of I3. I can take this I1 because I2 was at this point. I2 is coming, so I2 is positive. It is going minus of I3. It will be going this way, and this was the total current. So I can say this will be equal to I2 minus of 6 or minus of I3. I can take this. So this will be the I2 minus of 6 of minus of I3, and after at this point, coming at this point, the two currents, that is I1 minus of I2 plus of 6 is minus of I3 plus of I3. At this point we have I3 also. So these two current, when it will come at this point, we will obtain the value, that is I1. So this is the balance condition. That means the total of I that was coming is equal to the I1 plus I2 plus I3 is equal to 0. So this is how. Now we need to find out the, now we have distributed the current. That means I have to take the loops. We are going to solve for the three loops are needed because we have taken the three currents in it. That is I1, I2 and I3 are the three currents that we have taken. If it is not specified, I can go for the nodal analysis also, but we are going for the loop. By using the loop we are going to solve it. So this is how we are going to calculate. We have taken first, we have taken that is we have taken that was B C D H B, that is B at this point, C, then we have D, then we have H, and then we have B. That means we are taking this. Another one that we are taking is the another loop that we have taking is that is this one is taking. So that means we are taking this one, that is D. We are taking D, then we have taken E, then we have taken F, then H, and then D. That means this is the second loop that we are taking. Then we have the third loop, because this is the third. So how we are taking? We are taking the third loop, that is BHF, that is B H F G A and B. So this is the third loop we are taking. So we have 1, 2 and the 3 loops, and we need to calculate the, by using the KVL equation, what we will solve, we will take the current across this. In this 2 into, that is I1 minus of I2, because the current that is flowing in this is I1 minus of I2, it is flowing at this way. Then we are going at this point, no resistance is there, so coming at the D to E, then we have 10, that is the direction we have taken, that is I3. Then we have this value because resistance into the current. Then we have this value, that is 1 into I2 minus of I6. So this is how we calculate. The first equation is calculated. The second equation, we are going wherever there the resistance and the current will be multiplied across to it, but we have to remember the direction of the current. This is the plus of V and this is minus of V. So what we are going to take, V is starting from at this point, we are starting at this point. So for me it is 2 into, it will be 2 into I1 minus of I2 plus of 6 plus of I3. This will be the voltage across this, then it is going this way, so it is positive for me. Then at this point it is going this way, and the direction of the current is opposite. I have taken because I am going in this way, but the direction is coming this way, so it will be minus of 3 I2 minus of 6 minus of I3, and it again it is going at this point, and this we have 10, because the direction of the current, what we have taken, that is 10 of I3 is positive, will be equal to 0. So this is the equation that we have obtained, that is the second equation. Similarly, we can calculate the third equation across this. This will be somewhat, if we are starting from B, then we have the direction of the current, that will be the resistance into the current, that is I2 minus of I of 6 going this way. We are saying that the direction is same that we have taken, so the voltage drop across this will be the 3 that will be the I2 minus of 6 minus of I3 going back. Then we have the same direction we are taking, minus of 24 volt that we have taken, and we have one resistance across this, that is 4i1. That is, we have taken 4i1 because this was the positive current. That this is the third equation. So we have the three equations. By using the calculator we can calculate the current, by using this method we can calculate the I1, I2 and I3 can be calculated. Now we have next question that is saying, in a network this the V1 is 4 volt and V2 is 4 cos t. That means it has given the DC with the AC combination, and I3 is given, that is the current across I3 is given in the form of 2 e to the power minus of t by 3. So what we are going to do, we have to determine the I2. Let's see this, how we are going to solve this. We have this circuit. It is saying that the V1, the value of V1 is 4 volt, that has been given. This is sorry, this is this is the 4 volt that has been given. That is the value of, this is the V4. Sorry, this is V4. So V the V1 is given, that is 4 volt. Let me see where is V1. We can see where is V1. This is the V1. So V1 is given 4 volt. Then V4 is given. This means this one. V4 is given 4 cos 2 t, and the I3 has given. This is the current that has been given. That is I3 is given. That is 2 to the power t by 3, and it is asking me to determine the current across this. This is what we need to calculate. So how we are going to approach for this? We have the voltages are given. That means ki we need to V3. If I know the value of I3 is given, this is I3. So I can calculate the V3. So first thing that we have to take is that we have to calculate the value of V3. This V3, that means, so how we are going to we can see this is the inductor. So how we are going to calculate, we know the formula, that is V3 will be V is equal to LDI over dt. So by taking the L and differentiating the I3 value is 2 e to the power t by 3. So we have obtained V3. Now what we are going to do, we are going to use the total summation of the voltage should be equal to 0. That is was the KVL equation. So in this loop, if we are taking, if we are starting from any point, we can start. If I start from this point, this is 4 volt that has been given, which is positive. Then it is going at this way. This we have 8 farad. The V2 is given. That means we need to calculate the value of V2, and plus V3, because it is the direction it is taking, that is the voltage across this V3, and minus of V4. So this is how the KVL equation is applied. We know the value of V1, we know the value of V3, and we know the value of V4, that is given to cos of it. So by this we can calculate the V2 has been calculated. The V2 is calculated now, but it is asking me about the current. So that means I need to find out the current. So if we see, this is the capacitive circuit. This is the capacitive circuit. So how the current is calculated? C dV by dt. This is the value how we calculate the current across the capacitor. So we have the C value, that is given 8, and d by dt, and that means V2. We need the value of V2. We will put the value of V2 here across this, and we can calculate the value, that will be approximately minus this. So this is how we approach for the, if we have the AC and DC circuit with the capacitive and the inductor circuit. So this is how we solve it. Now we have another question which is saying that the find the current in an voltage across 2 ohm resistance. We have to calculate the value of the current and the voltage that is given across 2 ohm. This is a 2 ohm resistance that is given. So how we are going to approach? We see this is the current and this is the voltage. I can by using the source transformation, we can convert the current into the voltage. I can convert this, or we have this voltage, I can convert it into the voltage to current source. We have this. So how we are going to approach, which will be more helpful for me? If we assume that if I take this, if the current if I take the source transformation, it will be 5 5 25 volt will be going there, and the resistance that we are taking, that was in the parallel, in the current it is parallel, it will be connected with the series. And if it is connected in the series, we have 10 ohm resistance across this, and then we have the another voltage source, then we have 3, then we have 20 volt across this terminal, and I need to find out the value of this value, that is 2 ohm. So I can go for this, and this is connected with the circuit with a rectifier. So this is how we are going to approach. We have this voltage, because I can calculate the value of I1 and I2, I can calculate directly. So how we are going to solve this? We are going to take the two loops again with a source transformation, that is from the current to the voltage source we will be transforming it, and by transforming it I am going to make it little less complicated so that I can calculate the values, because the two loops I can easily solve it. So how we are going to solve this? What we have done, the same thing, these the source transformation, that is current to voltage, then we are transforming the whatever the is in parallel connect, which is the series with the 10 ohm, that is already the same circuit we have taken, the I3, and this is I2. So what we said, we have decided the current, because the current direction was not given, so I can say this was the I1 current, because the source transformation is done now. So if it is I1, and if I am taking this as a I2, so we have the two loops, that is I1 and I2. If I is the current that is going at this point, so if I take this I2, the current that will be flowing will be I1 minus of I2. So now we have the two again, we have the two equations we have, and by using the calculator, if I go for this, for example, if I show the one loop that we have, that is, if I start from this point, if I start from this point, the current direction is same, that is 5 of I1 I will take, then we have 10 of I1, then we have the voltage that is coming, that is a positive and negative, that is I have taken the 10 volt, now going downward, then we have a 3 I1 minus of I2, and again coming at this point we have minus of 25. So this is minus of 25 is equal to 0. This is the first equation that we are getting. Now coming at this point B2, we are going from this point. So how we will be solving? This is there is no resistance across this. So this is the 2 ohm. So first 2 of I2, it is going at this. Then we have minus of 20 volt across this. Then we are going opposite. We are going, as we can see, we have taken the direction that should go upward, but it is going downward. So it will be minus of 3 I1 minus of I2. So we have this equation as the second equation. By using these two equations, I'm going to solve the numerical. So the first thing that we have to remember, whenever the circuit is given, we need the current distribution. If we are doing the current distribution, then again you have to remember, when we are going for the KCL or we are going for the KVL equation, if we are going for the KCL, then we have to remember the direction of the current, that is we are taking. अगर हम direction गलत ले लेंगे तो सब कुछ हमारा गलत हो जाएगा. तो the first thing that we have to sign convention, that's why I said that sign conventions plays an important role. You can take your own convention, because what I have said, I take the convention that जैसे कि अगर कोई नोड पे जा रहा है तो मैं कहता हूँ जो भी करंट आएगी that will be the summation of 3. That means if I say this was the I1 is the current and it is going I2 this way, so I can say this will be the I1 minus of I2. I can directly say this, or I can say this कि if I1 was the current and it is going to distribute into two form, that is I2 and I3, then I will say that I1 is equal to I2 plus of I3 in this case. And if I go for this one, I1 is going to distribute into two form, that is this will be equal to I1 minus of I2 and plus of I2. I can say this way. Or if I say, if for example, if I take that key, the from the if from the node the current is going outward, so it will be negative, and if it is going inward, it will be the positive. So it is a sign convention that we have to remember. So you have to work on the sign convention. So the best thing is that take any numerical, take any convention that you prefer, that is inward or outward, and calculate according to it. Don't go for this, because in the books we will see everyone have a different concept of using it. I am taking the different concept, so you can go for that and you can calculate the values. That is for this equation, I can calculate the value, that is the first equation. Then we have the second equation, by using the calculator or by using the calculation we can calculate the voltage, that is the current we have calculated, and then the current will be multiplied by 2 into of I2, that will give me the 10 volt, that is the 10 voltage across this terminal. Now we have the another question that is giving, that is saying, using the source conversion technique. That means we have to use the because it has been specified. We are going to use the source transformation. So how? Using the source transformation, find the load current IL in the circuit shown in this IL. Where is this is the IL. So it is going to ask me what is the, if 3 ohm is there, what is the current of IL I need to calculate. So in this we can see we have the voltage source and the current source. What I can do, I can convert the current into the voltage, or I can convert the voltage into the current. What we are going to see, because it is simple for me, because this is connected in the series, so I can transform it. So the current will be approximately, that will be 3 ampere current that will be flowing from this, and this, the resistance that was 3 ohm, that will be connected at this point, and the 6 ohm will be connected at this point. Then it will take the 2 ohm, then we have the current that is given 3 ampere across this terminal, and this is the current that is 1 ohm is flowing at this terminal, and we have RL that is 3 ohm. So this is the circuit that we have obtained. Another way, what I can say, I can transform this current into the voltage. So let's see how we are going to solve it. This is how we are going to solve. This is source transformation. That means you can use the source transformation to calculate the values. So how we are going to calculate, what I have to, we have taken this, we have converted the voltage, into the current source, that I have made the diagram, and 6 is again in parallel. Now what we are going to do, the source transformation is taken, that is 2 ampere. Then we can see that 6 and 3 are in parallel. 6 and 3 are in parallel, so it will be 3 into 6 divided by 9 again. Then we can form that will be the uh, we can calculate 2 ohm. That is the equivalent resistance across this terminal A and B. That is A and B. That will be equal to 2 ohm. This 2 ohm is again in the parallel. Then we have the current source. Then this. Now what we are going to do, we can see that the two currents are flowing forward. The two currents are flowing. That is, again we have transformed it into the, again what we have done, we have transformed this again into the, first we have converted the voltage to current. Now we are converting current to, in this we are converting the current to voltage. We are transforming it to the voltage. So now we have the 4, 2 and 2 are again in the series, 2 and 2 are again in the series, that will form the 2 ohm resistance, oh sorry, 4 ohm resistance, and the 4 ohm will be something like this. This is the 4 ohm, this is the total resistance, and the one is the current. So the total voltage across this is 4 volt, and the 2 that was connected is converted into the 4. So now we have two currents across this terminal. What I can do, what I have taken the total current that is flowing in the circuit is 4 ampere, and this is the resistance that we have, that is 4 ohm, that is connected with the 1 ohm, and this. Now what we are going to do, without calculation I can calculate the value of IL. That was thus we have used the current division rule. We have used the current division rule, and by this I can calculate the IL value across this terminal. Now, these the earlier questions were based on the dependent, and that was independent voltage source. Now we have a dependent source. If you see at this is the dependent, that is dependent upon the I1, and I1 is the current that is flowing across this terminal. So in this, let's see this one. Find the value of V in the circuit. Where is the V? We have this value. It is going to ask me find the value of V in the circuit shown this. What is the value of dependent current source? And it is asking me what is the value of the 2i. So how we are going to solve it? We are going to solve it by simple way, because we know the KCL, and by using the nodal analysis. If I take the node analysis across this terminal, if this was given the 4 ampere and I1 was going from this way, so I can say the current across this terminal will be 4 minus of I1. I can say that because the 4 ampere current was coming and the I1 has gone at this way, so it will be the 4 minus of I1. It is the current that is flowing through it. Then we have, now we take this circuit, we are taking this circuit as the whole. So by using the nodal analysis says that if this is the voltage VA, VB, and if the resistors are connected across this terminal, and this terminal. So the sign convention is really important. If I say this is the I1, that is going to flow between this. If it is I2, so it is I1 minus of I2. I can take this way, or I can say if it is I1 and this is I2 and this is I3, so this is equal to I1 plus I2 plus of I3 will be equal, that is I1 plus I2 will be equal to I3. That means the total current that is coming will be distributed in terms of I3. So we have the three values, that is I1, I2 and I3, and I need to calculate the value that is across the two one. So by using the nodal analysis, we have calculated the current, that is V plus 6. If I know this value of the current, then I can calculate by using this node. I can calculate the value, that is by putting the value in this first equation. I can calculate that is V is equal to 12 volt. So this is how the voltage dependent source questions are solved. And it was asking me the dependent current source, the value what was 2I1. This was 2I1. So the I1 value we have calculated, that is V by 6. So the value is 4 ampere. So this is how we solve the dependent source. We have another question with us that is having a dependent source, and it is asking you by using the voltage divider rule, calculate the voltage Vx. That means it's a combination of, we are using the voltage division rule also, and by using the dependent source we are going to solve this. So how we are going to solve this? We are going to solve this by using this. We know that the values and the question, this is the another question we have, right one, this one. In the circuit, find the value of I and V. All resistance are in ohm. It is asking, this is a simple question that has been asked in gate also. So if it is the I is the current that is going, this is V by 4 and this is the plus of V, so we need to calculate, it is asking me to calculate if VA. Find the value of I and V. That's where is the I? The I is given at this point, and this is the voltage that we have right now. So this is how we are going to solve. We know that VA, this is VA. VA, this is the 2 into I. That means it is giving me the VA value is, if this is VA, so it will be 12 of 12 plus of V. That means this is the VA total, because the V voltage is given there and 12 volt is already existing, so it will be V minus of 12 of minus of V will be equal to 0, so it will form V is equal to 12V. So at 2 ohm we can calculate VA by, and by using again the nodal analysis, what we are going to do, by using the nodal analysis we have calculated the value voltage. Now coming at the third question, that is really very interesting. This look like very tough, but if we go for this, it is asking me the, by using the voltage divisor rule, calculate the value of Vx and Vy. This is Vy, and where is Vx? We have this value as a Vx. We can see that these two are in series, so that means the voltage across this will be the, these two are in parallel, that means the voltage of 12 volt should be equal to of this we have the then we have 12 Vx, that is equal to Vy, that means the 12 Vx should be equal to Vy. So by using this rule, we have, by using the voltage, we have calculated the across the 3 ohm. Where is 3 ohm? This is the Vx is given. So the total dependent source will be Vx, that is 72 volt. Then we can see 72 voltage drop is over the series combination itna and itna. Therefore, by using a voltage division rule, we can calculate this value, and Vx and Vy are calculated like this. So we need to be aware about the voltage division, how we. So we have the next question with us, that is saying find the value of I1, V1, Vx and VAB in the network if the terminal A and B are open. That means this is open. This means the voltage across this is the voltage across this. So how we are going to solve it? As you can see in the figure that we have, that means the I1. I1 is already given, that is given 4 ampere, and this will and we have to calculate the value of V1. So if we see this loop, if we see this one, how we have this one and we have another loop, that is this one. So how we are going to solve it? But if we see that the I1 is 4 ampere already, we have calculated. Now applying the KVL at the left hand loop, we have 20. This is 20 if we are starting at this point. If we are starting at this point, we have we will start from, that is V1, then we are going at the plus 40 and then minus of 20, that is equal to 0 if we are starting from this point. That means it is going in this direction. So this is negative, it is coming positive, so I have taken this as a positive. And this, if we are going downward, then we have this plus, and then we have the minus 20, that is equal to this. So we have the v1 value that will be equal to minus of 20 from this equation we have calculated. Now applying the KVL in the second loop, we have this one. If we start from, if we are starting from this point, for example, if I'm starting from this point, then I have minus of 4v1 as the polarity is this. Then going at this point, we have the 50 volt. Then coming at this point, we have this, have minus of v1, which is equal to, then we have this one, this is plus of Vx is left with us, Vx is equal to 0. So this was the KVL equation for the second loop what we have calculated, and by calculation we will obtain that Vx is equal to, if we go this one V1, this is 4, then it's 5v1, sorry, we have 5v1 with us. Then we have plus of this, will be going, this will be the minus of 50 and minus of Vx. So we have 5 V1 minus of 50, and then we have this value, that is Vx. So Vx can be calculated like this. The Vx value is 5v1, and we have calculated the v1 value at this point. So by putting this, we will have the Vx value that will be minus of 150 of volt. Now applying the KVL in the third equation, that is the third loop that we have right now. This is the third loop, that is open one. We will be taking the voltage, that is VAB. So if we are going to calculate that, then we will obtain that the third equation will be starting from VAB. If we take this, will be minus of 10, then we have minus of 4, then we have this equation, that is minus of 10 minus of VAB plus of 50 if we are going at this way, and minus of 4 this way. So this is the third equation. So by using these three equations, we will calculate the value of I1, we will calculate the value of V1, then we have calculated the value of Vx, similarly we have calculated the value of VAB. By putting the value, we will have the Vx value. If it want V1, V1 will be put in here, and VAB can be calculated directly. Now coming to the next question that we have right now. Now we have this question is there, which is saying that the by using the voltage division circuit, find the current drawn from the supply, the voltage across the resistors R, L, and fed to the RL, and then the tap to the circuit. Okay, let's go for this one. We need the circuit first. It is saying that show that the voltage divisor circuit, first the current drawn from the supply, the voltage across the RL, the current fed to the RL, and the current in the tap portion of the divider. So in this we can see, if we can directly see Vs, we have this loop with us, which is giving the this is 80 and this is 120, that means total 200 ohm is there. So, and this we have said the RL is equal to 3, and we need to find out the value. So how we are going to solve this? If we can see, it is a loaded voltage divided, then RBC, that is RBC, this one BC is divided into 120, and this is 80 total, 30, 120 and 30 is there. So we will calculate it by using this RBC. Similarly, VAB can be calculated, and the current can be drawn from this will be given. Similarly, VBC and the current fed to the load IL and current in the tap of the portion can be calculated according to this. Now we have next question with us, that is saying we need to calculate the value of the each branch of the circuit shown. So we have the two methods, that is the KVL. We can use the KCL method, we can use the KVL method, or we can use the node analysis. By using the node, we have the three nodes here. This will be the node. We can say it VA, we will say it VB, and we will take it VC. So by taking that also we can solve it. That will be much simpler. But if we are going to solve it by using the loop analysis. How we are going to solve it? We are going to solve it like this, like for example, we have the we have three loop. If I say that the current direction across this terminal is I1, and this across is I2, and across this will be the I3. So how we are going to write it? For example, if I1 is the current that is flowing across this terminal, and we said that it is I2, that means it is I3. So I can say that this is I1 and this is I3. So I1, this means that will be I1 minus of I3. We can say it I1 minus of I3. And if it is this, then it means key this was I2. I said this is I2. This is I2, that means this will be I2 minus of I1. This will be equal to I2 minus of I1, the current across this will be the I3. Now what we are saying, we are going to see the distribution. I said this is I2, that means it will be, if it is I2, then it is I1 minus of I2. So the current that has been given and the current that we have obtained is I1. So how we are going to solve it? We are going to take the three loops, and rather than getting too much, I will just see this. We have this. So we have taken this loop. We have taken this loop. For example, I am taking this loop. So I will be writing it. I will, if I am starting from this point. This is 30 I1 minus of I3. Okay. Then going downward, we have the we have 50 ohm that is having the current that is we have taken, that is I1 minus of, because the direction of the current is I1, this, and this is I2. So I'm going for this way, so it will be 50 I1 minus of I2. Then we have plus of 20. Then we have minus of 100. Then at this point we have plus of 6 I, that is equal to 0. So if we solve it, it will be 30 I1 minus of 30 I3 plus 50 I1 minus of 50 I2 plus of 20 minus of 100 plus of 6 I1, that is equal to 0. So if we solve it, we will have something that will be, if we take that will be 30 I1, 50, and then 6. And we have I2, that is 50 I2. Okay, so we have obtained 140 I1, that is 140 I1. Then we have I2, that is minus of 50 I2, and then we have minus of 30 I3 is equal to, that is we have 20 and we have 100, that is 80. So this is will be the first equation we have solved. Similarly, what we can do, we can calculate the second equation also. By using this, we can calculate the second equation, and then we, by using the equation, we can solve the we can calculate the value of I3 too. This is I1, I2, and I3. We will obtain the three equations that will be in the form of I1, I2, and I3, and we are going to solve it. So this is how the second equation has been formed. First equation, then the second equation, then we have the third equation, and by using this, we will calculate the I1, I2, and I3. Now coming to the next question. Using the mesh current method to calculate the current resistance R3, R4, it is going to ask me R3, R4, R5, and I6 for the circuit. So how we are going to solve it? We have converted this circuit, this one. We have converted this as an voltage source. What we are going to solve it? We will convert in a voltage source. If we are converting it 12 to the 24, then the resistance that was in the parallel will connect into the series. Then again we have the circuit. Now we will form I1, I2, and I3. That means the current that is flowing from the circuit, it will be I1 is going from this way, and it has been distributed into I2. This will be the I2, and this is the I3. So how we are going to solve it? We will obtain the same again. We will obtain the KVL equation, that will be 12 I1 minus of 8 in this, and we will obtain the first equation. Now going to the second loop, applying the KVL in the mesh, we are taking the mesh, then we have minus of 4 I1, that is a minus of 4 I1 6 into this. I2. Similarly, we will obtain the I3 equation, and by solving all these three, we will obtain the I1, I2, and I3. So it depends upon how we are going to, how much we have reduced. This is I told you that this that is source conversion. Source conversion is a tool that we are going to use it, and by this we are going to solve. So we have the next question with us that is based on the nodal analysis, as many questions we have done on the loop analysis and the voltage to current transformation we have done. So now coming to this, we have the two nodes, for example VB and the VC, and we said that the current is already given. That means we are saying that whatever the node that is going inside will the positive, and the node that is coming outside will be negative. I will take that. Whatever, if it is going inside the node it is positive, if it is going outside the node it is negative. So if we see at the point B, if we are going to see at this point B, what we are going to see, we are saying that the I1, this was the I1 that is going inside, so it will be the positive. I2 is coming outside, so I will say it negative, and this is going inward, so I will take it. How I'm going to write this? This will be I1 will be equal to the current I2 and minus of I3. I can write it this way, or I can write whatever it is going inside, it is positive, and what is going outside is negative. So this one is going inside, so I will take it as a positive. I can take this. So these two conversion, it can be written like this way or it can be written like this way. It depends what we are going to choose the conventions. So how we are going to solve it? We are going to solve it by using this nodal analysis, and with the nodal analysis we are using this concept, that is the current going inside will be the current that is going inside will be the positive, and the current going outside will be negative. So we will obtain this I1 plus I3 is equal to I2. Now going for the I1, if we see the I1, this was the VB. That means we are taking at this point. So the VB will be VB if I'm going out negative because the current direction I'm going to choose this one. That means it is coming inside. So it will be 15 minus of VB divided by the 1 ohm, means this circuit, this branch we have taken. Then we have another one that is VC, VB minus of VC, but the direction is opposite. So VC minus of VB divided by 0.5, this one. And again we have VB I2 is equal to VB upon 1. So this will be the first equation that we will obtain at this point node, at the node B. Now coming to the node C, what we are saying at the node C, the I3 is this way and I4 is going outward and I6, I5 is coming inward. So what we are going to choose, we are saying that that means the I5, I can write I5 is equal to I3 plus I4. I can write it like this, or whatever I said, whatever the things that is going out inside will be taken as positive, which is coming outside will be the negative, so it will be minus of I3 and minus of I4. So we got this key how the sign conventions we are going to take, and when we are taking the convention, that means now I need to find out the convention that we have taken. It will be going like this. As we said, if we see the VC, this is the direction of the current, that means VC minus of VB divided by 0.5, that will be VC minus of VB divided by 0.5, because this was called, now this one VC divided by, no voltage source is there, so VC divided by 2, and then VC, the opposite direction is there, so it will be 20 minus of VC divided by 1. So this will be the second equation we have obtained. So by using the second equation we have obtained, this one is the second equation. From equation we can say that the second, first and second we will obtain the voltage, that will be the VC value will be approximately 11. VC we have obtained 11. Now we can calculate the value of VB according to this, because we said that the 15 minus of V1 upon 1 is equal to, or we can say VC minus of V2 divided by 0.5. So by using that we will obtain the value of the current I1, I2, I3, I4 and I5. Now coming at this question, this is saying that to find the current in the figure by changing the two voltage source in the equivalent circuit and by using the nodal, all the resistance are in ohm. It is saying change the two voltage source in their equivalent current source. That means it is asking from voltage to current source, and then it is saying that use the nodal analysis. All the resistance are in the ohm. So how we are going to solve it? We are going to solve it by this way. It has said that it have the two voltage source, that is V1 and V2. What we are going to do, we are going to convert into the current source. As we said, when we are going from the convert, it will be coming in the parallel. So this will be the circuit if we say that A, B and C if we are taking. So this will be the A, this will be the total B, and this will be the C. So we have obtained the current source for this. 4 volt has been converted into current source. Then we have the 3 volt that has been converted into the current source again. And by this we are going to solve it. Now we have the nodes, different nodes. If we apply the node 1, 2 and 3, 3 nodes are there. How? Node number 1, because we said that the node is defined as a point where the two or more branches meet each other. At this, 3 points are there. At this, 3 point is there, and 3 points are here, and 3 point is there. So what we are going to do, third point, if we are not considering the third node also, we will consider the fourth. If we go for this one, if we will say that this is, we will be writing it like this: V1, V2, and V3. We have V3 minus of V3 minus of V1 divided by 1. V3. This is V3 divided by 1. This plus 4, that means the direction of the current is 4, is equal to how much? This, this, and this. So it will be equal to V1 divided by, that is at this point. Where is V1? This. V1 divided by 1, because the voltage, because the resistance is 1. Then we have plus V1 minus of V2 divided by 1 plus 5. This was the current that we have. So this will be the first equation. Now coming at the node 2. Where is node 2? This one. So how many of them are? The I current is flowing this way, and this has been transformed into 2 form, that is 1 and 2, and this is going at this point also. So it will be this and this. How we are going to write it? We will be writing this: the 5 ampere current is coming inside, plus V1, that is, where is V1? That is V1 minus of V2 divided by this will be the second equation. Now at the third node, we will calculate the third node, and by using this three nodes we are going to calculate the current, that is V1, V2 and V3 can be calculated according to this. Now we have the next question with us, which is saying that find the voltage and the current through the 2 ohm resistance by using the nodal analysis. It is asking me across, find first voltage V, that is this voltage. Then it is saying that the current through 2 ohm resistance. Where is 2 ohm resistance? This is the current. This is asking me the I value across this. How? This is the dependent source. As we can say, this is written 5V and this is V. So the V value is somewhat we need to calculate. So how we are going to solve it? We are taking this node and we are taking two nodes at a point. We are taking the two nodes. If I say this as a VA and this is as a VV, so it will be the current. If I say the direction of the current I have chosen, like it will be upward and this will be going from this to this. So it will be 6 minus of VA, 6 minus of VA, because the direction is taking this way, divided by the total resistance, that is 1. It is going to be distributed into two parts, that is I1, we have calculated this one. Then we have VA, that is if I take this direction, that means it is going upward, so it will be from 5V minus of VA divided by 2. This one, 5, we are starting at this point. 5 VA minus of VA divided by 2 will be equal to the current I3, that is simple, VA minus of VB by 3. So this was the first equation we have generated. Now we will solve it for the we will calculate the value of VA, and by this we will obtain the 6 minus of VA, and this is how the current and the voltage across the 2 ohm resistance can be calculated. Now we have the next question here. We can see solve the circuit showing by using nodal analysis. It is saying by using the nodal analysis, I will take add this as a node, add this as a node, and this as a node. And this all are combined at this point. You know what? I can draw this figure like this. If, for example, if A, then B, then C, and this all are connected at the point D, I can make it as this. So this is the neutral point, I can say. That is the common point for all. So according to this, the current is going this way. For example, I take the current direction as this, and the current direction that was taken is now, I will take randomly. For example, I take this one and I take this one. Then it means the current direction is this one. That means all are coming outside. So I will, using this, I will be saying that the way V is a dependent, so I'll take it further. So V is will be equal to the divided by 1 upon 50, that is this value, plus 1 upon 2.5, minus of VA minus of VB divided by 2.5, that is this one. And by using this equations, now taking at the B node, if we say that the current direction is going this word and this one and this word, this will be VB divided by 20, VB divided by 20, that will be in that, by this we can calculate. And at node C also we can calculate. So by using these three equations and by using the nodal analysis and by this, we can solve it and the value can be obtained